Okay, welcome to this question here, 2018 question C1 higher level. The accompanying map located on the back of section A shows ground contours of 5 metre vertical intervals. The motorway is widened between B and C to form a toll plaza. The portion of A to B is level at an altitude of 65 metres. The portion of B to C is level at an altitude of 65 metres. And the portion from C to D is rising uniformly at a rate of 1:15. Using side slopes 1 and 1.5 for cuttings and 1 and 2 for embankments, complete the earthworks necessary to accommodate the motorway between A and D on the northern side. Okay, so we'll start here at section A. We got to think, is this an embankment or is it a cut? The road is level at 65 metres, and the answer is that it's an embankment as the numbers are lower than 65. Now the scale is 1:1000. The vertical intervals are 5 metres. So 5 metres equals 5,000 millimetres. So 5,000 millimetres divided by 1,000 equals 5. So 5 metres equals 5 millimetres on our sheet. Right now, so for an embankment, the scale or the ratio is 1:2. For every 5 we go down, we go out 10. So the distance between our lines are 10 millimetres. Okay. Right, now, just one sec there, I'd turn the lights are after dropping in the room. Okay, there we go. Right, so what we say there, 60. So this is 65. The next number is 60, 55, 50. Alright, this point here is at 65. 60. Okay, 55, 50, alright, and then, sorry there, I hit the table, and then 50 again, if we had it to be somewhere around there, okay, and you don't have to be precise once the map goes out, and so we can join these points together, your tadpole for an embankment, sorry. That's there. Now, this here, right, this part of the toll plaza, look at the numbers here in the contour. They're what? They're above 65, so this is a cut. Alright, the ratio for the cuts is every 1:2, 1.5. So for every 5 units I go up, I'm going out 7.5. Okay. Right, so that's at 65 there. This will be at 70. Numbers rise in numerical value for a cut. 75, 80, 85. Apologies for any background noise. 90. Okay, now we're going to draw in our lines parallel to the edge of the roadway. So now 65, 70, 75 is there. Now, even though our 80, so our first 80 follower, 80 is there. Now, go again then with, that's as far as we need to do. Next 80 won't hit it. Alright, so what we're going to do is sketch these in lightly, because The reason being is because the earthworks here is going to intersect that one there. Right now, what is this earthworks here? Is it an embankment or is it a cut? So you need to think about that. Alright? And the answer is it's a cut because the numbers are above 65 again. Right, so we're going to mark in every 7.5. Right, and we're going to draw lines, as you know, parallel to the edge of the toll plaza, nice and long, because it's going to intersect with the earthworks on the other side. So lines across there. I could do it in UT square, it's getting old. 65, 70, 75, 80, 85, 90, 95, 100. Okay, so our first 70, or sorry, not our first 80. So our first 80 would be over here, and we'd have a 75. Okay, there. Now, then our next 80, so 80 here, 75 there, 75, 80, 85, okay, 90, right, even though the 90 never hits it, okay, you want to pretend they're going on further so they intersect the one over here, even though I know it never, like the edge of the road would never actually hit it, but you pretend as if this goes on for longer so you can figure out where they intersect. Like for example over here, I'm going to, like, here are the points here we've done, so I'm just going to sketch 3 of them in here. Its intersection between the last one is right there. So a heavy line there, and now you can heavy in this portion of the earthworks, and that's a cut. If you can figure out that another name for that line, you'd be doing well. I'll say it in 1 minute. Okay, I'll go back to here. 90, 95, 100, and 100 there. So lightly we do them. The answer to the name of that line is a trace. Okay, so that's lightly done. We have to do the cut for this side here at this edge of the toll plaza. Then we'll do it. So, well, I shouldn't have said it was a cut. I should have waited for you guys to figure that out. Okay, so I'm going to draw a line perpendicular to the edge of the motorway. Okay, actually I'll do it here where there's less lines there to confuse you. Okay, and we're going to plot the distances along it, so every 7.5. Okay, and then we can draw our lines perpendicular then to that or parallel to the edge of the roadway. So you want to keep these on going nice and far for this question because of the fact there's an inclined road from C to D. Makes it a little awkward, okay, in terms of space on your sheet. Right now, so the edge of the road is at 65, so 70, 75, 80, 85, 90, 90, 95, 100. Okay, so we would, if the toll plaza went on further, we'd have a point down here, okay, and then at 75 we'd have one here, and now the 80 will be here, and then there'd be another 80 over here, 75 then again here, another 75 here, and 80, 85. Okay, it's where the 85 altitude line is intersecting with the 85 contour line. Okay, so 85 is done, then 90, 95, 100. Okay, and I can bring these two lines on. Okay, I feel I'm a small bit inaccurate up there, up towards the top here. Okay, a small bit, not much. Right now, we would lightly sketch these in together. Where's my 100? There's my 100. So it's a bit awkward here now sketching this in with the visualizer on. Now I'm going to heavy these in later. Okay, I would always say keep your hand inside the curve. So as I said, it gets annoying when you're doing it on the visualizer. Okay, leave this light here now. This is the point at which the earthworks here, the cut here, intersects with the cut there. This one right there. So I join a heavy line there again. Now I can heavy in the earthworks over here. And again, can you remember what is the name of that straight line I drew in? That is called a trace, okay? It's called a trace. It's two planes intersect at a line known as a trace. That's a key DCG principle. Alright, now, we're going to, before we heavy this in, cut, head going out, we got to do this area here. So C to D rises. So imagine this pencil as the roadway, C to D rises. C is at an altitude of 65. The question says that it's rising uniformly at 1 is to 15. So for every 15 meters you walk, the road rises by 1 meter. So if I walked 75 meters, so from my left hand to my right hand, if that was 75 meters walked, I would have to rise up by 5 meters. So what we're actually going to do is we're going to mark a line or a point that's 75 long. And the reason I picked 75 is because 75 divided by 15 equals 5. Okay, so this x is at 70 meters. Now, this area here is what you call it, a boat, an embankment, and boat a cut. What will this one here be on the left of it? Okay, on the left of it, it'll be a cut because the numbers are above 65. On the right of it, the numbers are below 65. So it's an embankment. They're below the level of the road. So they are. Okay, so as I was saying, it's an embankment here, a cut there. Now, for a cut, we're going to start with our cut. You always put the circle at the lower end of your road for a cut. And you got to do it. You got to figure out, okay, just do a bit of rough work here. So, for a cut, you got to figure out the height of the cone. Okay, so the distance between the lower point and the higher point, it's 5. And the ratio, you sub the altitude of the cone into the ratio to get the radius. So the radius in this case will be 7.5 because the altitude is 5, and 5 multiplied by 1.5 equals 7.5. So we're going to go back to our question now here, or back to the other side. We're going to draw a cone with a radius of 7.5 from point C. Okay, and we're going to draw a line from point X that's a tangent to the cone. Okay, and this line is at 70. Okay, it's at the altitude. The line is always at the altitude of the base of the cone. So now we're going to do our, sorry about that. Now we're going to do our lines parallel to the edge of the cone. At 7.5. I'm going to mark in our 7.5. We got, how many do we have? I'll just do 3. So that's 80. So that's 75. That's 80. And I want to do one at 65 to help me. Alright, so I'll go 7.5 down. Okay. So at this rate, it's getting like rather messy with lines. So I'm just going to look. I'm just going to start marking points. I'm not going to draw in loads of lines. Okay, and I'm going to write C for cut to help me. 70. C for cut. And then 75. C for cut as well, and then 80 for cut as well. C, and then I want to do what you call it. I want to do one over here at the other 80 contour. C for cut. Okay, so I'm going to sketch them together. Okay, as I know, I'll heavy them in later. So that's the end. Okay, now where these intersect, this is the point that our previous earthworks end at. So now here we can start heavying in that earthworks. And then I'm just going to rub out those lines there that I left in from my sketch sitting in my seat, which, as I said, is quite awkward. Now, our next thing to do is we have to do the section of the embankment. Now, for an embankment, the cone always goes at the higher end of the road. And the ratio for the cone, or for embankments, is 1:2. So, the radius of our cone will be 10. Now, where did I get that from? Because the altitude of the cone was 5, and 5 subbed into the formula of for every 1 unit you go down, you go out 2, will get me the 10. So I've drawn in my semicone there. I'm going to mark this, I'm going to draw a line that's a tangent there. Okay, and then I'm going to mark lines perpendicular, and I'm going to apply the same idea just to lower the workload as the last time. We will just mark points there. Now, the altitude there, alright, so the number you start with here is always where the base of the cone is at. So the base of the cone is at 65 there, and the further you go out from the cone, the lower the numbers get. So this is at 60, this is at 55, this is at 50, and then we go one down there just to help ourselves. So that's at 70. Okay, the 70 is just a simple construction, right? So where 65 intersects 65 is here. So E for embankment. Okay, where the 70 would intersect 70 would be there, E for embankment. Okay, 60 so E again. 55 again, E, and then there'd be E again for 55. For 60, E again, 55, and then 65 will be down here, and there's no need to go on any further than that. So then we're going to sketch in our points, alright? There's my first one. I'd lightly join them here. Now, and where they cross over, we mark where they cross over, that's where we go heavy in. Now, there is actually there is actually like a line there. If you compare it to this one there is in real life a line there. So there is. But you don't have to draw it in if a cut section on an inclined road meets an embankment section on an inclined road. I don't know why you don't have to draw it in these questions, but in real life there would actually be one, because two planes intersect at a line. Again, as we spoke about, a key DCG principle. Alright, so our cut, this is our cut here, so, and this is our embankment, and this is our cut here. And now, the next part of this question, and probably in this particular one, my favourite, bearing in mind we've got 25 minutes gone in the video, and you should get these questions done in, you should get these questions done in 35 minutes max. So it says P, Q and R are 3 points on the, P, Q and R are 3 points on the surface of the earth. Okay, so P, Q and R are on the surface of the earth. 3 points on the, or vertical boreholes at these 3 points reveal a triangle on the top surface of stratum of ore at altitudes 45, 60 and 35 respectively. So P, Q and R are on the Earth's surface. When they're drilled into the ground, they reveal points at those respective distances. So I'm going to write slash P1 here, slash Q1, slash R1, just so we know, alright, that they're R and R1 they're not actually the same. R1 is down lower than R. Right, so the question says we have to draw the elevation of that surface in the space provided at the top of the map. Draw the elevation of the triangular surface of the top stratum. Part 2, draw the plan of the triangle and determine the strike and dip of the stratum. So, they give you an altitude line of 35 here. So, point R1 is at an altitude of 35. Q is at an altitude of 60. So we measure up 25 from 60, or 25 from the 35 line, because 35 plus 25 gets us 60. So there's Q1. Okay, and P is at an altitude of 45. So how far do I measure up from the 35 line? What do you think? I'll measure 10, because 45 minus 35 is 10. Alright, P1. So we join these together. That's our elevation. Okay, now, the strike is a level line across the surface. Now, what they mean by level line is they mean that it's horizontal. Alright, so a level line is always horizontal in elevation. So this is an elevation here, and the map is a plan view, even though there's contours on it. So you can pick anywhere you want on your elevation and draw a horizontal line. Okay, and that horizontal line is the true length in plan, because if a line is parallel to the XY line, okay, we'll just pretend the XY line is there, it's the true length in plan. And to see the angle between two surfaces, so the dip is the angle between the triangle, the surface, and the horizontal plane. So to see them, you need to see both planes as an edge. The horizontal plane in an auxiliary elevation will always appear as x1 and y1 line. And a surface projects as an edge when any line on that surface projects as a point. And a line will project as a point when you look along its true length. So if you look along the strike, it'll appear as a point up here, and the surface, PQR, rests on, will appear as an edge. So just to clarify, I drew a line across, dropped it down where it hits there, joined it back up with R1. I'm going to look along R1, alright, and I'm going to project Q1, the same angle there, and R1 at the same angle there, and we have to draw perpendicular to that. Right, so we have to draw a line perpendicular to that for x1, y1 line. So I'm using my sliding set squares, protractor, or whatever you want to do. Okay, there's my x1, y1 line, so I'll just zoom up here. Okay, you can start wherever you want, or on this here, if you choose so. Okay, but remember the distance have to remain the same. I'm personally going to start at 0 here. I'm going to measure up for Q1. I'm going to measure up 60 because it says the altitude is 60. Okay, so there's Q1. For P1 it's 45. So I'm going to measure up 45, and R1 it's 35 here. Okay, we join these together. Now they should all make a straight line. Immediately I can see that that didn't make a straight line there. So I'm going to just check my measurements again there. I'm looking at an awkward angle here as I do it. So there's 60. Alright, there's 45, and there's 35. So the issue here that's gone wrong with me is that the problem is down here with the angle I took. Alright, so I'm just going to solve the problem there. It's the angle and the projection angle that I went off. So I'll pause the video and fix that. And here's my error here. My strike, whatever, my set squares moved when I was doing this. See the inaccuracy. So I go into I'm going to rub out those old projection lines just in this area and put in the new ones, okay? So there, I re-changed it there. So I'm going to put the dimensions on it again. So 60, okay? 45. And 35. And there, we join them up now, and there's the surface PQR appearing as a line. So the question now asks for the dip. So what's the angle between the horizontal plane, the X1, Y1 line, and the surface PQR? So I extended my X1, Y1 line there. You don't necessarily have to do that. Okay, and I'm going to extend this line down here until they intersect. That's the dip there. I suggest you measure it. Where is my protractor? I tell you, some of my 6 years are in trouble for taking my protractor. So they're cheeking them. Okay, I'd suggest you measure in the angle, and the dip there is 45 degrees. Okay, you can also do the dip, okay, and measure the dip. If you don't want to extend on your X1, Y1 line and your surface, you can draw a line parallel to X1, Y1 line, measuring the angle there. They're alternate angles. The next part of the question says, a vertical borehole from ore. So, determine and indicate, or sorry, not a vertical borehole. Determine and indicate in meters the length of the shortest skew borehole from ore, alright, to the top of the surface of the stratum. So it's not ore1, it's ore, alright. So we got to measure up 80. So there's ore. Now, the shortest distance between a point and a plane, so this, it says the top surface, so this is an edge of the top surface. The shortest distance between ore and a plane, or the shortest distance between a point and a plane, is a perpendicular line from that point. And in order to draw a perpendicular line, you need to see the plane as an edge, which is exactly what we see over here. So we draw a line perpendicular to surface P1, Q1, R1 from point R there. And that is the shortest distance. So it says determine and indicate in meters. Alright, so it says indicate. So you have to measure this, okay, and write it in meters. So it's 33 millimeters. So that in meters is 33 meters. Watch that they don't have the scale 1:500. That'd change things. Now, this is my favorite part of this question. Alright, it says, determine in plan the line of intersection between two top surfaces, between the top surface of the stratum and the surface of the widened portion of the toll plaza. So this really goes back to intersecting surfaces in our section A. So we got to extend the edge U of this surface here. We got to extend it on. The toll plaza is at an altitude of 65. So we're going to measure up 65. Alright? And the toll plaza appears as a line. Okay? Because the toll plaza is parallel to the horizontal plane, and the horizontal plane appears as the x1, y1 line. So we're drawing in a line parallel to the x1, y1 line. That is 65 millimeters from the x1, y1 line. And that is a point view of the line of intersection. Okay, and now I'm going to project this point view back down here. Alright, so I project it back down here and I extend it on, and this is the line of intersection. LOI. Now, if I was setting this exam paper, I'd go just one step further. I'd ask you another question. I'd say, show me where the dihedral angle between the toll plaza, or the surface of the toll plaza, and the top surface of strata is, so the head wall. I'd ask that. Now, I know some people at this stage when they do it don't know what this means. But the dihedral angle would be right here, because the dihedral angle is seen in view, showing the two planes as edges and the line of intersection as a point. So there's the toll plaza as an edge, and here's the top surface of the stratum as a line. Cheers, thank you, bye bye.